Hi everyone, welcome to my YouTube channel. In this video I am going to explain one of the important special function, that is Legendre's function and its recurrence relation. In the previous video I have explained you what are special functions and what are the kinds of special function. So Legendre function is one among them. How we get Legendre's function? Legendre function we obtain with the help of Legendre's differential equation. So as you can see, this is the standard equation for Legendre's differential equation of second order. So it is given by 1 minus x square d square y divided by dx square minus 2x dy by dx plus n into n plus 1 into y is equal to 0. So the solution of this Legendre's differential equation of second order is given by y equal to a into Pn of x plus b into Qn of x. So the complete solution of Legendre's differential equation consists of two functions here, Pn of x and Qn of x. So Pn of x we can obtain due to the condition k equal to n. Okay, there are two cases. So Pn of x is the solution of Legendre differential equation of first kind. So second kind is given by the condition k equal to minus n plus 1. So Qn of x. How the value of Pn of x we obtain by using power series method by putting k equal to n. This is the standard equation for Legendre's differential of first kind. Pn of x, you can note down this equation, very important. And when we get second kind Qn of x, that is k equal to minus n plus 1. So this is the standard equation of Legendre's differential equation of second kind. Okay, Qn of x and Pn of x makes the complete solution of Legendre's differential equation. So Legendre's function is denoted by Pn of x, that is called first kind, Qn of x that is called second kind, due to the given conditions. So once we get the solution of Legendre's differential equation, we should know generating function. So generating function of Legendre's differential equation, that is Legendre's function, is given by 1 minus 2xt plus t square to the power minus 1 by 2. This is what the generating function of Legendre's function Pn of x. Okay, Pn of x we can obtain with the help of this Legendre's with the help of this generating function. 1 minus 2xt plus t square minus 1 by 2 is what? Generating function. Generating function means we can generate the Legendre function Pn of x with the help of this equation. So once we understand the generating function, we can obtain the recurrence relation with the help of this generating function for Legendre function. So recurrence relations. What are recurrence relation for Pn of x, that is Legendre's function Pn of x? Relation among various orders of Legendre functions are known as recurrence relations. So as the name indicates, relation among various orders of Legendre's function, we can call them as a recurrence relation. So first we should write the generating function, that is 1 minus 2xt plus t square to the power minus 1 by 2, which is equal to summation of Pn of x t to the power n. Okay, this is the generating function for Legendre's function. Next, what we have to do, we have to differentiate this equation with the help of, with respect to t. Whatever the recurrence relations are there, we can obtain with the help of generating function by differentiating with respect to t and x. So first let us differentiate with respect to t. Okay. So let us consider this equation as 1. Okay. So differentiating equation 1 with respect to what? T. So here 1 minus 2xt plus t square is there and RHS at t to the power n. Then so if we differentiate with respect to t, we can get 1 minus 2xt. So minus 2xt is there. However, this is minus 1 by 2. That is, you can consider it as x to the power n. N equal to what? Minus 1 by 2. If we differentiate, we will get minus 1 by 2 into, inside the bracket, you should differentiate with respect to t. Differentiation of 2x is what? Minus 2x. 1, 0 we will get. So t square differentiation to t. Keep as it is this entire term, and you should take power of n minus 1. Okay. Differentiation of x to the power n is what? N into x to the power n minus 1. So we will get minus 3 by 2. RHS side, keep as it is summation Pn of x and differentiate with respect to t to the power n, that is n into t to the power n minus 1. Okay. Once we differentiate with respect to t, next what we have to do, here minus 1 by 2 is there and inside the bracket 2 minus 2x plus 2t is there. Then 2 to get cancelled, we will have x minus t and keep as it is this term. So next, but this term what you have to do, 1 minus 2xt plus t square minus 1 by 2, keep as it is, and RHS side you can take power of 1, the entire term power of plus 1. You can shift it to the RHS side. This is plus 1. Okay. If you add this term, again you will get minus 3 by 2. Okay. If it goes to the numerator, it will become plus 1. Then keep as it is the next term. Next what we have to do, let us consider this equation as 2. Okay. Equation 2. Then using equation 1 and 2, we get equation 1 is what? The generating function of Pn of x. Equation 2, after differentiating with respect to t, we will get equation 2. Then substitute here the entire term. Whatever the RHS side 1 minus 2x t plus t square is there, replace with Pn of x t to the power n. Okay. Then RHS side keep as it is. Next what we have to do, we have to equate the coefficient of t to the power n on both sides of the equation 3. Let us consider this as equation 3. So equation 3 we have to equate with respect to t to the power m. What we have to do here, if you want to equate, let us consider n equal to m. Okay. Let us consider n equal to m. Yeah, if we consider n equal to m, then the LHS side of equation will become Pm of x into t to the power n. Okay. So this will be x P m of x. One second. So this term, what we can do here, x into pm of x minus m minus 1 x. How we get this? By equating the coefficient of t to the power m. That is, here inside the bracket x is there, t is there. So x into pm of x t to the power m we will get first term. Okay. If we multiply t to this t to the power n, it will become t to the power n plus 1. This term n, and here t is there. It will become t to the power n plus 1. So we have to equate t to the power m coefficient. Then what we have to do here? If it is n plus 1, we have to take it as m minus 1. If we substitute, we will get the coefficient of t to the power m. So this will be what? N equal to m minus 1 we have to take. This is plus 1. So here t to the power m coefficient, if we equate, we will have m equal to n equal to m minus 1. So pm minus 1 of x is equal to the RHS side. First term as it is, n equal to m you have to put and equate the coefficient of t to the power n. Here it is n minus 1. Then n equal to what we have to put here? M plus 1. Okay. Because it is n minus 1. So m plus 1 if we put, first term we will get, that is n equal to t to the power n minus 1 is there, pn of x. So n equal to what? M plus 1, and pn of x we can get pm of x first term. Okay. That is what? Coefficient of t to the power m. So next, second term minus 2xt is there. Then what we have to do? Here we have to take it as 2x as it is, n equal to m, that is t equal to n equal to m if we put, keep as it is m, pm of x, and t to the power 1 is there here. So n minus 1, 1 get cancelled. So you will directly, you can write the second term, 2x m into m of x, because it is consisting of t to the power 1. So 1 get cancelled, we can equate to t to the power m coefficient. Third term, t square. So next what you have to do here? T square is there. So here t to the power n minus 1 is there. So it will become n plus 1. This power will become n plus 1. At that time, you should put n equal to what? M minus 1 for third term. Then you can make it as the coefficient of t to the power m. So here n equal to m minus 1 if you put for third term, you will get m minus 1, n into, it is there, m minus 1, p n, p m minus 1 of x, and this is what? Coefficient of the third term. Okay. So you should keep in mind, if you are equating the coefficient of t to the power m, then whatever the terms involved in the equation 3, you should make it or reduce it to the t to the power m coefficient by substituting n value. Then you will get equation in terms of coefficient of t to the power m. So next, you should just evaluate RHS and LHS side. You will get the first recurrence relation here. So 2m plus 1 x into pm of x. So here x into pm of x is there. So here pm of x it is. Okay. If you bring it to the LHS side, you can write 2m plus 1 x into m plus m of x. So you should take this second term to the RHS side and just add it to the m minus 1 term, you will get m plus 1 pm plus 1 of x. So third term, that is m into m p m minus 1 of x. Okay. So this term you should keep as it is, RHS side first term, and second term you should take it to the RHS side. You can get m into m minus 1 of x. When m is replaced by m minus 1 in the equation 4, so equation 4, if we write, we have to replace m by m minus 1. We have this relation 2m minus 1 into x pm minus 1 of x, m into pm of x plus m minus 1 of pm minus 2. This is the second recurrence relation. This is quite easy, you can obtain. For first recurrence relation, you have to differentiate with respect to x generating function. Then you should equate t to the power m coefficient, and you will get the first recurrence relation. So second recurrence relation you can obtain by putting m equal to m minus 1 in equation 4. So this is second recurrence relation. Okay, you can note down all the recurrence relations. If you equate LHS and RHS side, you can write the equation like this: m into pm of x 2m minus 1 into x pm minus 1 of x minus m minus 1 pm minus 2 of x. This is second recurrence relation. Only thing is you should replace m by m minus 1 in the above equation. Here whatever m is there, m minus 1. Okay, next. So third recurrence relation we can obtain by differentiating the generating function with respect to x. So we have differentiated with respect to t. Okay. Next what we have to do, we have to differentiate with respect to x. 1 minus 2xt plus t square minus 1 by 2, and that is equal to pn of x t to the power n. So let us differentiate with respect to x. So if we differentiate with respect to x, in this only the second term minus 2xt is there. So these two terms will be considered as constant. They will become 0. Minus 2xt inside the bracket, and this is x to the power n. Okay, n into n, x to the power n minus 1, we have to make like that. So with respect to x, equation 1. So we will get minus half minus 2t into 1 minus 2xt plus t to the power 2 minus 3 by 2. Okay. Then keep RHS side. This pn of x will become p dash of x t to the power n as it is. So here 2 get cancelled. It will be t into inside the bracket this term, take it as minus 1 by 2, and one more term you can bring it to the RHS side. It will become plus 1, power of plus 1. Then keep the second term as it is. Then using the equation, let us consider this as equation 5. So equation 1 and 5. Okay, equation 1 and 5. Equation 1 is what? Generating function. this one 1 and 5. So we can write like this. This term is replaced by Pn of x t to the power n in equation 5, that is t into summation Pn of x t to the power n, and keep as it is the RHS side. Next, similarly we have to equate the coefficient of t to the power n, t to the power m in equation 6. We can take this equation 6. Okay. So equation 6, t to the power m coefficient. This is t to the n equal to m. Let us take n equal to m and equate with respect to t to the power m. So here t is there. If you multiply, it will become t to the power 1 n. T to the power n plus 1 we can write it. Okay, 1 is there. Then we can, if it is n plus 1, t to the power n plus 1, then we have to put n equal to what? M minus 1. Okay. Then the LHS side of equation 6 will become P m minus 1 of x. Then this will become, after putting n equal to m minus 1, t to the power m. So coefficient of t to the power m in LHS side is what? P m minus 1 of x. So RHS side. So there are three terms, 1 minus 2xt plus t square. So first term, if you take n equal to m, if you put the first term will be as it is, p prime m of x. Second term minus 2xt, and here t to the power n is there, here t to the power 1. So again it will become n t to the power n plus 1. Okay. Then we have to put n equal to m minus 1. Second term will be minus 2xt p prime m minus 1 of x. So third term here t square is there. So t to the power n plus 2 it will become n plus 2. Then n equal to what we have to put? N equal to m minus 2 we have to put for third term. Then we can make it as t to the power m. So the coefficient will be p prime m minus 2 of x. So this is the equation 7, we can take it as, this is third recurrence relation for Legendre function. After getting the equation 7, we have to replace m by m plus 1. In the equation 7, we get another recurrence relation. So m minus 1, it is, if we make it m plus 1, m plus 1 minus 1 get cancelled, we will get Pm of x, LHS side. Then RHS side, first term P dash m, we have to replace it m plus 1, m plus 1 of x. Second term 2x p prime m minus 1, that is 2x p prime m of x. Third m minus 2 is there, m plus 1 if we put, minus plus 1 minus 2, that is m minus 1, p prime m minus 1 of x. This is the fourth recurrence relation. Okay, you can take it as equation or else just you can write as it is. So here just interchange the terms. LHS side you can make it as p prime m plus 1, p prime m minus 1 one side, and RHS side that is equal to pm of x, 2x p prime m of x. So this is the required recurrence relation. This is fourth recurrence relation. take it as equation 8. So, sixth recurrence relation we can obtain by differentiating with equation 4 with respect to x. Fifth, this is fourth one recurrence relation, and this is fourth one. Okay. So third one is given by this one, Pm minus 1 of x. Then next for fifth recurrence relation we have to differentiate equation 4 with respect to x. Equation 4, 2m plus 1 into x Pm of x, m plus 1 Pm plus 1 of x plus m into m minus 1 of x. So whatever the x terms are there, we have to differentiate. After differentiating, we will get 2m plus 1 into x into Pm prime of x plus 1 with respect to x and 1 with respect to Pm prime of x. We have to differentiate. LHS side we will get 2 terms. So RHS side of equation 4. So m plus 1 of x, we will get P prime m plus 1 of x, and last term m into m P prime m minus 1 of x. So after differentiating, let us take this as equation 9. Okay, then multiplying equation 9 by 2. Equation 8 by 2m plus 1 of 2m plus 1 and adding the two products. So equation 8 and 9 we have to consider. After doing this multiplying and dividing, we will get 2m plus 1 into Pm of x plus P prime m minus 1 of x is equal to P prime m plus 1 of x. This is the sixth recurrence relation. Okay. So the last one we can write by replacing m by m minus 1 in the above equation, that is equation 10. Once we replace m by m minus 1, the last recurrence relation we obtain is 2m minus 1 Pm minus 1 of x P prime m minus 2 of x P prime m of x. These are all what recurrence relations. So what we have to do? First thing is to write the generating function of Legendre's function Pn of x, and after writing generating function we have to equate with respect to x and t. Okay, with respect to t, if we differentiate, we will get two recurrence relations, that is this is the first recurrence relation by differentiating with respect to t, and this is second recurrence relation. So next what we have to do, again this generating function we have to differentiate with respect to x. Once we differentiate with respect to x, we will get other two recurrence relations. This is equation 3rd and equation 4th. Okay, these all are what the recurrence relation. This is 4th one and this is the 3rd one. So the last two recurrence relations we obtain with the help of equation 8 and 9. Okay. So these are all what? Recurrence relations. This is sixth one. So this is how you can obtain recurrence relations for Legendre function with the help of generating function. I hope this video is helpful for you. If it is helpful, please like, share and subscribe my channel. Thank you for watching.